Projectile motion is talking about an object flying through the air. It's something that's maybe hit or kicked or thrown, and it continues until gravity basically pulls it back to the earth. It doesn't have an engine, so it can't fly on its own. So if we're going to graph something, a projectile motion graph, we have the x-intercept representing time, and then the y-intercept is representing the height of that object. So if we look at the y-intercept intersects the y-axis. So that means at this point, time is 0. So what does the y-intercept actually represent? It represents the initial height of the object, where that height was at the very beginning, before any time has passed. So if you kick something from the ground, its initial height might actually be down here at the origin. If you throw it and you're 5 feet tall, that y-intercept, the initial height might be up here at 5. How about the vertex? Well, think about the coordinates x, y of the vertex. This is the highest point on our graph, so it's going to represent that highest, the top height, your maximum height, and the time when that happens. Well, since x deals with time, your x-coordinate will be the time when that ball reaches its maximum height, and the y-coordinate will actually be the maximum height of that object. And then finally down here, the x-intercept, all the way down here, your y-coordinate is 0. So this has to be the time where that object actually hits the ground. So the time when the object hits the ground, you're going to be able to calculate that once you solve a quadratic corresponding to this particular parabola. Let's take a look at an actual example here. We have the equation h of t equals negative 16t squared plus 108t plus 4. And that represents the height h of a ball t seconds after it is hit by a baseball player. So what should you do if you want to find all of these things? Well, I want you to take a second and pause and see if you can write out what you would need to actually find. So I'm looking for answers like x-intercept, y-intercept, x-coordinate of the vertex, and y-coordinate of the vertex. Then we're going to use Desmos to actually find those things. So we really already discussed what each of these are. So the initial height of the object, if we want to find that, we want to find where no time has passed on our graph, which occurs at the y-intercept. So to find the initial height of the object, you need to find the y-intercept. If you want to find the time when the object reaches the maximum height, well, time is always an x-coordinate of a point. So which point is it? Well, when it's at its highest, you're talking about the vertex. So in order to find that, we need to find the x-coordinate of the vertex. If you want to find the actual maximum height, the maximum height is the y-coordinate of that vertex. So it's the maximum height, meaning the vertex, height, meaning y-coordinate. So find the y-coordinate of the vertex. And the last thing you need to find when the object hits the ground, that's when the height is 0. And we know that that occurs at the x-intercept. So you want to find the x-intercept there. So now let's go ahead and plot this in Desmos and find each of those items. So go ahead, open Desmos on your computer and see if you can find these along with me. So if we have h of t equals negative 16t squared plus 108t plus 4 in Desmos, then we're going to have, initially the graph doesn't look great, only because it's really zoomed in. So you're going to want to zoom out. And unfortunately, when you zoom out like this, just to even see the vertex, it's really not conducive to reading what's going on here. So I'm going to click on the settings, and you can actually change what you want your x-axis and your y-axis to go from. I'm going to go maybe from like negative 5 up to, you shouldn't have to do too far, maybe 5, a positive 5 there. Let's see, it's going to let me delete all that out. Let's just go up to, or even, let's see, that might not be enough. About 8. Yeah, that looks pretty good. And even that helps enough. We can see enough of the graph right there. So if you remember, if you click on the graph, you're going to be able to find some of these points that we want. So like if we want the y-intercept there, if you click, it's going to show you actually where that point is. But we know the y-intercept is always going to be that constant right here. So we know that if we're looking for the y-intercept, our initial height of the object, it would make sense that it's going to be 4, in this case, what is it? Well, we didn't really say, so we'll just say 4 units. It's actually supposed to be in feet, so just go with feet for me. Then the next thing we need to find is the coordinates of the vertex, which we have right here. So 3.375 and 186.25. The 3.375 is going to be the time, right? That's the x-coordinate, so 3.375 seconds. And then the y-coordinate of the vertex we know is that maximum height. So that's going to be 186.25 feet. So 186.25 feet. And then the last part, the x-intercept, we can go over here, and the x-intercept is 6.787. So that means it takes 6.78 seconds for that to hit the ground. 6.786 seconds for it to hit the ground. So in the next tutorial, you'll learn how to deal with more of these projectile motion equations.